Okay, you have on slide number 15, you have a question about extravascular multiple doses. So we have a drug with 1 to 8 nanogram per milliliter, a therapeutic window or therapeutic range of the desired average steady state plasma concentration is 6 nanogram per milliliter. Determine the dose orally if taken twice daily. Sorry. So if we are talking about twice daily, which means that tau equal, right? Which will be equal to 12 hours. So you are taking the drug each 12 hour, and the systemic clearance, absolute bioavailability, .5 liter hour kg, and this equals to 0.45. Okay, so the question is determine the dose. This is what we need. Again, it's a super duper easy question. So it's extravascular, so we need to have this equation, K VD tau. Okay, this 0.15 liter hour kg. Don't forget that we have it per kg and there is no weight. This, the one that you want, this equal 0.45. This is 6 nanogram per milliliter, and this is 12 hours. Okay, so the dose that you will have be equal to 0.024 nanogram per kg, or in other words 24 microgram per kg, and it should be per kg because you didn't correct for the weight. Okay, the other question is, again, in the extravascular route as multiple doses, as you saw from the slides, it's easy as concept because you know it. Just know the differences between the extravascular and IV bolus of whatever I explained, but make sure that when you substitute the numbers you do it right, because it's just about crunching the numbers on your calculator and do it right. So just practice it. This question, just practice it and try to find another question in your textbook or reference box, so it's easier for you to know where the parentheses should be, which steps to start in the equation, because the equation is a bit longer, so you have more numbers in it compared to the IV bolus. So the adult male patient with 46 years old, this is the second question on your 16th slide. 46 years old, age is 81 kg, age weight 81 kg, and age is 46 years old, right? 81 kg, was given a dose of 250 milligram of tetracycline hydrochloride orally every 8 hours and for 2 weeks. From the literature, tetracycline hydrochloride is about 75% bioavailable, so F is equal to 0.75 and VD equals to 1.5 liter per kg, which means that it's 1.5 multiplied to 81 kg, okay, which will be equal to 1 to 1.5 liter. And we have elimination half-life that is equal to 10 hours, which means that K equals 2.693 over 10 hour minus 1. This is K, and then it's giving you that Ka equals to 0.9 hour minus 1. Okay, from those information, calculate C max of a single or first dose. Again, to have Cmax, it means that we need to determine Tmax. First dose, it means that we have N equal 1. Okay, so accordingly, you can either go with whatever the full equation that we have for this model for multiple doses, but I didn't give you how to determine Tmax of different doses other than steady state. So by default, you will know that you need to determine this, as you know already from what we had already of a single dose. So you have this is 0.9, 0.00693, 0.60693.9. Tmax will be equal to hour. Okay, using the equation of a single dose, this will be equal to Ka minus K. Remember this equation? And we need to add this as Tmax, right? Again, you have all the parameters that you need. 0.9. This equal to 5 milligram. 0.75. And this equal to 1 to 1.5. You have this 3.08. You have this and this 308. And again, just double check my calculation. This is 28 milligram per liter. Again, double check my calculation. Okay. This is for the max. Then the question is asking you about the minimum for the first dose. Minimum will be at time equal tau, and the dose will be N equal 1. Okay. Thank you. No. Okay. So the same thing is here, but you need to use T equal to tau. Okay, so go and use the same thing, but just add tau equals to 12 hour. And again, it's just direct substitution of numbers and the equation, and you will have C minimum for a single dose that is equal to 0.96 milligram per liter. Okay, it's not 12 hours, sorry, this is 8 hours. Okay, it's 8 hours. 12 hour was for the question before that. Okay, and again, double check the numbers. This is second, third. We need the plasma concentration. We need the plasma concentration at 4 hours after the 7th dose. Okay. Again, you need to use the long equation that you have for this. If you notice, it's just sample and direct. تعويض مباشر. So the only thing that you need to make sure that you are doing that in the right way. Okay. And I shouldn't videotape this, but just to make sure that I'm telling you that, because you need to have those questions full in the exam. Okay. Again, dust ratio of the elimination plus Ka tau multiplied G minus Ka with T. Okay, everything that you have, the only thing that you need to make sure of, this is 7, this is 8, again 8, 8, 8, and this is again 7, and this is what? 4 and 4. So just add the equation as it is. Don't use your mind in the exam. Just write it down, add the numbers like this, and then start to add numbers using the calculator to make sure that you are doing it in the right way. Okay, and this will be giving you 2.86 milligram per liter, and double check the number for me. Okay, the one before the last question, I need the maximum concentration at steady state. This is for D. I need the minimum concentration at steady state. Okay, to determine this should be equal to infinity, right? N equal infinity, and this is time equal T max at steady state, right? It was T prime or T max at steady state. Okay, if you go and use the equation for the steady state, you will find that T max will be equal to 0.6 hour. Okay, and for the whole concentration, I will give you just the last number or the last answer, and go and try it with yourself and see if you can do it. Okay, for the minimum, it will be this as time equal to tau, which is 8 hours, and this is n equal infinity. And again, when n equal infinity, here and there, this will go. Okay, and with tau, this will be tau, and this will be tau, this will be tau, and this will be tau. Okay, and the overall concentration will be equal to 2.26 milligram per liter. Your numbers may be a little bit different than mine, depending on the how much you'll do multiple approximation while you are working on it. So I may have some decimal points different between my numbers and yours. Okay, for the last one, which is the average steady state concentration, it's F dose K VD tau. Again, you have this 250.75, 0.0693, 1 to 1.5, and this is 8 hours, and you will have this as 2.78 milligram per liter. Okay, and by this I just finished this video.